We are a company called PrivaSapien. We are into privacy and responsible AI. In this session, we are going to look at some pets in action. So it was really exciting to see a lot of pet demos or topics. In fact, Lee's presentation just before, the point where we ended is where we are working on a foundational model for synthetic data with differential privacy. That is one of the products. So we'll try to see some of the demos as well live in terms of products. So it's not just pets, but there are certain set of technologies which are needed along with pets when we speak about auditability, verifiability, and using these in responsible AI scenarios. Primarily, this is a data in use problem, as we know, and as NIST defines, putting this into a framework actually helps us define the problem statement better and then look at solutions. So, three key attributes of privacy enhancing technologies are dissociatability, predictability, and manageability. And when we have these capabilities, then it becomes much more easier to define how much can we dissociate the data source or the data subject from the data, and how predictable is the data, and how manageable is this dissociation and predictability. When these are defined and definable, then it becomes a much more proper privacy enhancing technology. So this understanding, it's very important to establish in the market, which is a challenge today. People a lot of times even confuse between security and privacy, of course, in the market side. So when we put this data in use protection, it falls into two broad categories at the data level and at the model level. Data level, there is privacy management. It is very important to understand privacy management because then you can ground it on consent and then do pets on top of it. And that interrelationship is also very important to understand the risk. Then subsequently at a model level, data collection, model training, model assessment, model deployment. And then now guardian agents are beginning to come up. And then internet of agents and internet of responsible agents are also shaping up. So this whole spectrum, right from privacy management till guardian agents, is considered AI tourism. And this is the framework that Gartner has come up with, which is pretty exciting. So we have tried putting the privacy enhancing technologies and the technologies within pets that we have already implemented in this chart, along with others as well. So this is a 2 by 2 matrix where the x-axis is from input privacy, which is cryptographic in nature, to output privacy, which is more statistical in nature, and y-axis is from data querying to data sharing, so primarily interactive to non-interactive. And we have technologies like k-anonymity, t-closeness, differentially private data sharing, synthetic data. All these are mitigation technologies, and the risk identification technology is very important in terms of, especially in terms of data sharing, which is called privacy threat modeling. So while pets mitigate the risk, PTM identifies the risk in data flows, and it is very, very important to understand what is the risk. And integration of PTM and PET will play a very, very important role in auditability and reliability of solutions in the future. Then subsequently on the querying side, of course, you have differentially private querying, synthetic prompts, federated learning, which is also sort of a querying mechanism. And on the cryptographic side, there are things like data in use, pseudonymous inference. We would see if you can do a quick demo of that. And then small language models, which are guardians in understanding the risk, the equivalent of PTM during the inference side of things, in usage in data querying at a model level. Then subsequently on the cryptographic side, we have things like PSI, SMPC, threshold cryptography, then ZKP, and confidential compute. The confidential compute is bit at the boundaries, but yeah, it also plays an important part. This is a broad spectrum, and we have already implemented and deployed the ones which are in green in the platform at enterprise grade, and we are serving our customers. This is our full platform. We call it as Perai, which includes the DPTM, which is data privacy threat modeling plus privacy enhancing technologies plus responsible AI technologies. So if you look at the data and AI lifecycle in an enterprise, it starts with consent. So can we make consent verifiable and provable and withdrawable along with cookies and rights and incidences? Then all data flows in the enterprise should be bound to this consent, and in terms of pet it can become exempt if the right level of guarantees can be provided. But even before that, we have to understand the risk in a data which is being requested. That's where privacy threat modeling comes in, where you can do attack simulations of data, because globally privacy means, like, in a data, what is the level of re-identifiability today. Like typically in the market, the understanding, it's like if there is PII, then it is personal data, and if it is there is no PII, then it is anonymized, which is technically not correct, as we know. If it is relatable to an individual, and multiple instances have happened in the past, so if it is relatable to an individual, then it is considered a risk. But there is no quantification mechanism today to quantify what is relatable, while those are defined in things like GDPR, like singling out attack, linkage attack, inference attack. So we have done one of the first of its kind privacy threat modeling implementations of doing this attack simulation of singling out, linkage, inference, outlier attacks on data, and quantifying the risk in the data for both structured and unstructured data. For structured data, we have a product called Privacy X-ray. For unstructured data, we have a product called Nebula. And this goes into DPIA, which is, we have a product called Prescriptron, and we have an agentic version of DPIA, once again, a very revolutionary product called Agent Plateau, which can converse with data requesters and mention what is the level of risk in a data request, and make summarize the data request, and also make recommendations to the DPO of the technical mitigations they have to put in place. Once this is done, the next phase is the PET phase, which is where the mitigations actually happen. So if the data is considered to be risky, then you can do, let's say, in HIPAA privacy rule, there are exemptions for expert determination method, where you have K anonymity, T closeness, and differential privacy combination. So we have a product called Event Horizon for that. Cryptosphere is for cryptographic data collaboration for data in use. Data Twin is for training data. This is for application development and other purposes. Clonelum is for model training with synthetic data. Differential insight is differentially private querying of data. So these are the set of pet technologies. Along with we have a new category called pseudonymous inference, which is in Ragam, where you can use pseudonymous data for inference with large language models. And then during the large language model deployment, before the deployment, how do you quantify the risk in models? With agentic AI red teaming. So we have a product called Agent Turing, which can interact with models and quantify privacy, safety, security, fairness risks in a model. And then based on that, AI impact assessment can be done with Ethicstron. And then once the model is deployed, we have a small language model guarding large language model called ROI, Responsible AI Fire LM. It's like firewall for Gen AI models. And then Ragam is for RAG assessment and mitigation, which also extends into prompt level safety, security, and fairness. So this whole stack is available in a platform. It's a pioneering work. We have filed around 40 patents on this across the spectrum. Um, and this provides an enterprise an ability to share data. Let's say today they are sharing data with multiple parties. The problem is post consent they cannot share data with, let's say, sales, marketing, if it is not consented, and that's a big challenge. And then downstream they will be sharing with multiple vendors, and then they will subsequently be sharing. So with traditional methods like discovery, this becomes a big problem because it is not scalable anymore. And similarly, when you put certain kinds of control, it becomes a bigger challenge. But when you do pets, it can significantly unlock data, as you know, across the business ecosystem. So in real life, we have deployed it in multiple customer scenarios. So some of the use cases are like for application developers, we can provide synthetic data, which is not possible in the earlier scenarios where the risk is also high and the utility is also low in the earlier generation test data kind of situations. So with synthetic data, which we are doing with what Lee was mentioning subsequently of, foundational model based differential privacy is what we have already implemented, and we have put in our mathematical proofs as well. I will show that as well shortly. So those are available on the platform. Then subsequently, if you are sharing data with for analytics and other purposes, there are bigger challenges of breaches in downstream ecosystems. So if you can do grouping based anonymization kind of techniques, then that can be of huge value. Similarly, you can do differential privacy as well, which also we support. Similarly, for payroll processing and kinds of those where you require pseudonymization to be in place for re-identification for data in use, those are supported. We are beginning to do some level of polymorphic encryption and homomorphic encryption as well. Um, in terms of sharing data with external large language models, like we were rightly concerned about memory of external large language models. So how can you identify this right at the user level, and you know let's say confidential IP, financial, medical, personal information? So we have built a Gen AI firewall which can sit between user and the external large language model, identify the sensitive information, pseudonymize if there is sensitive information present along with the context. We capture the context in a very specific way so that the downstream model does not lose context despite pseudonymization. And then the answer from the model is like pseudonymized. So we have integrated it in a very special way. And this can be re-identified downstream before exposing it to the user. So this is like we have multiple deployments on this on the customer side as well. Similarly, when organizations are training or fine tuning models locally, fundamental problem is limited data for fine tuning. But with synthetic data with utility that we are building now with mathematical guarantees and differential privacy guarantees, it can significantly increase the amount of data available. And then subsequently, once the model is trained, we also do agentic AI red teaming. And then subsequently, during the deployment, we provide Gen AI firewall, responsible Gen AI firewall during inference. So thus, it provides a very unified approach for deployment, right from consent to threat modeling to different kinds of mitigations of anonymization, synthetic data, tokenization, differential privacy, and pseudonymous inferencing, and using the data for different business use cases. For example, discounting based on loyalty trends, or AI model training, or third party data sharing with controls in place beyond sharing. um, Insights for business analysts to use cases like data protection while inference with a downstream model with pseudonymous inference. So with this, privacy and responsible AI are no more cost centers. They actually become profit centers because you can unlock data and model for new revenue generation and risk mitigation. And this is the platform. So if you look at it, it's this is a Kubernetes based deployment which can be in a customer ecosystem. So you can define users, their roles. You can build connectors to different databases in the customer ecosystem, and then there can be different tables within those databases. You can edit those and then configure different attributes of it. Then subsequently, you can connect with applications, configure applications, collect consent, collect DSR tickets of different applications, and ensure that the data is protected when users want to do specific kind of things in their data flow. Similarly, when data needs to be deleted, then you can apply patches on the data before deleting the data, and the location of the data can be tracked via DPIA and then subsequently ROPA for corresponding users, and understand where and all data has flown for specific users in specific scenarios. So consent, integrating with consent plays a very, very important part. Then a very interesting part is privacy threat modeling, where before it's like, you are checking your blood sugar levels and then taking medication for reducing the sugar level. So while the medication for reducing the sugar level is PETs, doing the sugar test in your blood is like PTM, privacy threat modeling. So we can connect to different data sets, quantify the risk in data. We can do privacy attack simulations on data, and for different data types, it can have different levels of risk. For example, you can see if some of them have risk of 51, some of them have a risk of 15, which is very less, some of them have a risk of 100, which is very, very high. So let's say you're trying to understand a risk in data. So you can see that this risk is high, which is 100. And there are two kinds of risk quantification. One is Pixar score and other is Pixar index. Pixar score is like a qualitative risk index, so which is between 0 to 100. And Pixar index is a quantitative index. So it is a delta between 2 points in time, how much of data minimization you have done. So if you have done data minimization or reduce the number of columns or put more controls in multiple columns, then the risk would come down from, let us say, 940 to, let's say, 450, right? So in that, it does auto classification of PIIs, unique identifier, quasi identifier, statistical data, time, and other attributes. And then it also does a subtype classification within that, like what are those 5 PIIs, for example: name, email address, phone number, social security number, postal address, etc. Similarly, not just does only for PII, but also for like things like quasi identifier. Then it also tries to do attack simulations on data, like singling out attack, linkage attack, inference attack, and tell you how much of risk is present in the data. Not just that, based on that, it also links to what kind of technical regulatory requirements are there connected to a clause like a regulation. Let's say GDPR resale 26, which speaks about anonymization and differentiation between pseudonymization, and at what point it becomes exempt from the regulation. And then what does NIST framework provide? So all this information are very critical for a DPO, so that he can connect the, lot of times DPOs are from legal background, so they need to connect technology to the legal language so that they can take decisions on top of it. So thus, we start with a mathematical background and then connect it to a legal background and say how it has to be handled. And then subsequently, how should an organization build their privacy journey from identify, govern, control, communicate, protect, which is the NIST framework. So how do we solve it is what we provide. And also for attributes, we mention what kind of attributes are present at different data. So that's a very quick overview. There are a couple of other products as well. For example, let's say CloneLM, where we can also show you like what kind of mathematical proofs are present for synthetic data. So like what we were discussing earlier, foundational model based synthetic data with differential privacy is generated, and then it provides PC and other analysis information. One last product is Ragam, which enables you to pseudonymize data for inference. For example, let's say there is an application form, and it is going to a downstream LLM model. It understands the risk in the data, quantifies the risk in data, pseudonymizes. It can pseudonymize, redact. Different kinds of controls are available, and based on that, this information can be used to do a inference with a downstream model as well while it is pseudonymized. Let's say I'm asking what is the customer ID in the document. So real time, so it'll understand the document is being attached, and you can see that the information which is going to a downstream model, which went to the downstream model, and the inference coming from downstream model is pseudonymized, while you can locally re-identify, right? Thus, sensitive information never flows to a downstream model, while user gets all the benefit of using this with privacy protection in place, right at the very beginning. So that's the quick background of the platform. Yeah, thank you so much. If there are any questions, I'll be happy to take it.